Is everybody there?
Yes, doctor.
Yes.
All right. Okay. So now we'll see a different method, yeah, to analyze the protein, yeah. So previously we saw NMR, yeah, to see the structure of molecule, which is protein, yeah, and also to see the three-dimensional structure of protein. Now we look at another method, yeah, which is less complicated, yeah, to get information about the identity of a protein in terms of their sequence, yeah. So which is spectrophotometry, mass spectrophotometry. Okay, so mass spectrometer, yeah, mass spectrophotometer can be used to see the sequence of protein, yeah, unknown protein, especially the protein that we isolate from a biological sample. Yeah. So what I'm going to talk now is the application of mass spec. Yeah, we call it mass spec. Yeah, tak larat lah, mass spectrometry is too long. Yeah, so we are quite lazy, so we call it as mass spec. Yeah, or MS. Yeah, mass spec or MS. Yeah. So we are going to see the application of mass spec, yeah, in solving a real biological problem. So in this case is to identify an unknown protein. Yeah. So the example that I'm going to show you today is the proteins that we isolate from a cancer cell. Yeah. So if you have cancer patient, yeah, normally they don't show any symptom. Yeah. So that's the reason why treating cancer patient is difficult, because they come to hospital when there are symptoms. Yeah, when there are symptoms. So I don't know whether you have met Prof. Mahiran, yeah, Allah yarhamah Prof. Mahiran, yeah, from Department of Chemistry. She passed away in 2017. Yeah, I guess you were not in UPM at that time, yeah. But her office is a fourth floor, yeah, next to my office, yeah. And she was my supervisor when I did my PhD in UPM, one of the co-supervisors, yeah. It's a very nice lady, yeah, very nice lady, yeah. So I treat her like my second mother, yeah. Because when I came to Malaysia, I was alone, yeah. I didn't have family, yeah. I was so lonely in this country, and Prof. Mahiran understand that. So sometimes she called me to her office and then talk to me about my life, you know, about my study and everything, and then we share stories about our hobbies. You know, it's just like my mother, you know. So it's very nice lady, yeah, and everybody loves her. Everybody loves her, yeah. And she became a pengarah Pusat Asasi Pertanian, yeah, before she passed away. Yeah. She passed away because of cancer. Yeah, she passed away because of cancer, and the symptom is very trivial. The symptom is something that everybody feels. The symptom is back pain. Back pain. Yeah. So she always feel this back pain. Yeah, back pain, and then, but because she's busy, yeah, she's busy with research, with teaching, with as a director of ASPER, yeah, and she ignores that. She ignored it, yeah. She just took Panadol, and then the pain goes away. Yeah? She ignores that, and then again another back pain, another back pain, another back pain, and then she took Panadol, and then the pain goes away. Until one day, her friend told her, "Prof, why don't you go to hospital and check? Because your back pain is it comes regularly." Oh, okay. I go to hospital, and then Prof. Mahiran went to hospital, and when doctors check, and then doctors say, "Prof, this is cancer." It was shocking, because the symptom is I think people, even people, you know, at my age, we start feeling some back pain because we are getting older. You know, we are getting older. We have less calcium, and then yeah, because of, you know, the grease in our bones are decreasing, so that's why we always get this back pain. But most of the time we take it as normal. Yeah, it's normal signs of aging. Yeah. So doctors say, Prof, this is cancer. It was shocking. Yeah. And I think it was in 2015. And for the next 2 years, she spent her time with chemotherapy. And unfortunately, she couldn't survive. Yeah. It cost her life. You know. And yeah, I was lucky that I met her a few months before she passed away. Yeah. She was ready at the time. She was ready in Serdang Hospital. Yeah. I visited her with my friends, you know, former her former students, and then she was ready. Yeah, she told everyone, I'm ready. Yeah, because she knows it's not curable. It's not curable. Yeah, she's ready. Her face is very bright and clean. You know, she prays a lot, and she's ready. Yeah. And when she passed away, and I was lucky that I can attend her funeral in UPM cemetery. Yeah, like like a lot of people came, you know, because during her life she touched so many hearts. You know, that's how nice people, when they die, a lot of people come, a lot of people pray for her. You know? So yeah, it starts with normal back pain. You know, it starts with very simple symptoms. You know, so when you feel pain, don't ignore it, because when you feel pain, that's the way your body tells you something is wrong. Don't ignore. You know, don't ignore. Please check. You know, because your body always tells you some sign if something is not right. Yeah. And you don't want to suppress the signal by taking Panadol or by taking any painkillers, because you suppress the signal. Yeah. And when you suppress the signal, your body will stop telling you that signs. It will stop telling you warning. You know, your body is nice enough to tell you, hey, something wrong in your body. You know, please take action. You know, so in most cases, cancer patients, they see doctors when they have symptoms, and when they have symptoms, the cancer is already not in stage 1, in stage 3 or 4. It's very difficult to treat. Yeah. Okay. But fortunately, yeah, using protein chemistry, we can detect cancer in a very early stage without waiting for symptoms. Yeah, without waiting for symptoms. In this case, yeah, this is an example how we detect adenocarcinoma, yeah, one type of cancer, using mass spec, yeah, using mass spectrometry, yeah, by identifying the protein that exists in cancer cells that don't exist in normal cell. Okay, so because when you got cancer, your cells will produce new proteins. Yeah, will produce new proteins that don't exist in healthy cells. That's how we differentiate between cancer cell and healthy cell, by looking at the different proteins that is expressed in cancer cells, that you don't get it, you don't see it in healthy cells. Okay, so, and how we do that? We can use mass spec. So that's how chemistry step in. So chemistry and biology, they always work together. You know, there is no biology without chemistry, and there is no chemistry without biology. Yeah. So that's how chemistry step in. Yeah. That's how mass spec is used to detect the protein that only exists in cancer cell. We call this protein as marker protein. Yeah. As marker protein, because the presence of this protein mark the cancer cell. Yeah. The existence of this protein indicates that the cell is cancerous. Yeah, it's a pancreatic cancer. Yeah. So the way we do analysis is by isolating the protein, yeah, and we do electrophoresis using SDS page. Yeah, I hope you still remember. Yeah, my second lecture about protein analysis. Yeah, so we run a SDS page in 2-dimensional SDS page, followed by mass spec. Yeah, either MALDI-TOF or MALDI-TOF-TOF. It's very sophisticated machine. Yeah, I was lucky that I had experience running my experiment using this machine. In Malaysia, we have several places, yeah, equipped with this machine. We have in UPM, yes, we have MALDI-TOF, Sunway University, UKM, they have this machine. It's very sophisticated machine that you can use to detect the presence of proteins in cancer cells. Yeah? So we can detect the cancer as early as possible, even when the symptom is not there yet. Right. So this is the principle, as I explained to you. So the protein, yeah, are different between cancer cells and healthy cells, yeah, between normal and tumor cells, yeah. So we can diagnose cancer if we are able to identify, we are able to ID, yeah? ID is to identify, yeah. So to identify marker proteins for early diagnosis. So this is what we want. Everybody should be diagnosed as early as possible for cancer. Yeah. For male, now it's possible. Yeah, we call it as a PCA. Yeah, I forgot the full name of PCA. Yeah, to detect the prostate cancer. Yeah, when you are 50 or 40 or 50 years old and older. Yeah, it's advisable that you start doing PCA. Yeah, to detect the presence of prostate cancer as early as possible, without waiting for symptom to appear. Yeah. But for other cancer, it's still difficult, yeah, because not many people, they are aware, yeah, that this is important to detect cancer as soon as possible. Yeah. What people are doing now is to detect the possibility, yeah, not to detect the presence of cancer cell using this method. They detect the possibility of them getting cancer by analyzing their DNA. Remember in my class, I told you that once I analyzed my own DNA, remember? Yeah, I analyzed my own DNA. From there, I know that what kind of disease that can potentially happen, yeah, during my lifetime. Yeah. And by analyzing your DNA, you can actually detect the DNA that potentially cause cancer. This is what Angelina Jolie did. Yeah, you know Angelina Jolie, right? So a few years ago, yeah, she decided to do mastectomy, yeah, to remove her breast, because by analyzing her DNA, she can detect that she has that DNA that is responsible for breast cancer. She didn't have breast cancer. She didn't have any symptom, and she checked, she langsung tak ada. She didn't have breast cancer, but from her DNA, it tells her that yes, she has that potential to have breast cancer. So she decided before the breast cancer comes, she decided to do mastectomy to remove her breast. Yeah. So it's very brave action. It's very brave action because breast cancer, there is no medication for that. Yeah. So yeah, that's how people are doing now. Yeah. They check from their DNA what kind of disease that could happen, yeah, in the future, and they take action early before that disease happen. Yeah. All right. So and it's cheap, you know, to analyze your DNA. It's very cheap. It's $99, yeah, per analysis. Yeah, it's very cheap, basically 400 ringgit, 500 ringgit, and you know everything about you. Okay. So in this case, they use mass spec. Yeah, this is the mass spec they use, MALDI-TOF and MALDI-TOF-TOF. Yeah. This is the goals. Yeah, we want to detect PDCA as early as possible. Yeah, because pancreatic cancer is the leading cause of cancer deaths in Western world. Yeah, 40,000 deaths per year in Europe. Yeah, 28,000 deaths per year in USA. So we want to avoid this death. Yeah? Almost always advanced when diagnosed. As I told you, cancer patient, they always go and see doctors when there are symptoms. Yeah. Long-term chance of survival less than 5%. It's very serious. It's very serious. Yeah. So getting early diagnosis is very important. And mass spec can help us to detect this cancer as early as possible. Okay, so this is where biology and chemistry step in. Yeah. So we do electrophoresis on tissue preparation. Yeah, tissue that we took from the patient or suspected patient, yeah, because they don't get cancer yet. Yeah. So this is normal cell, and this is tumor cell. Yeah, you remember from my lecture. Yeah, this is electrophoresis. You run on gel. Yeah, and from here you can see some new spots. Some new spots, very tiny spots, sometimes very tiny because it's early diagnosis. Yeah, early diagnosis. So that's why the spot is still very small, but it's there. Yeah, the spots are there. Yeah? So what you need is you just have to cut this spot. Yeah, cut using scissors. Yeah, just cut it, yeah, from the gel, and you extract. Yeah, remove it from gel, and then you send for mass spec, and you identify the protein. That's it. Yeah, you run the electrophoresis to separate the proteins. You pick the spots, yeah, that you found in tumor cells, but they are not in healthy cell, and you extract from the gel. You digest, I mean you cut it into smaller fragments, so it's easier for mass spec to detect. You send to mass spec, and you identify the protein. Sample preparation is not easy, yeah, because you are working with cells, yeah. So as you can see from this electrophoresis, hundreds of proteins in cells, from blood, from the cell itself, hundreds of protein, hundreds of spots. And you must have good eyes to see which spot are new, which spot only appears in tumor cells but not in normal cell. So you cut it, you excise the spot from 2D gel. Yeah. You require some skills to do that. Yeah, it's not easy. I did it once. Yeah, it's very difficult. Yeah. So, and what kind of mass spec techniques suitable for the sample? And MALDI is one of the good techniques. What MALDI, I will tell you in the next slide. This is MALDI. Yeah. So MALDI means matrix assisted laser desorption ionization. Yeah, MALDI. So your sample is mixed with a matrix. This is a matrix. Eh? This is matrix. Yeah, mixed with matrix. And then you ionize the sample. Yeah, ionize the sample with matrix. Yeah, and then you get the ion. Once you get the ion, then mass spec can detect. Yeah. So why you mix with matrix? Because you don't want to destroy your sample. Yeah? The presence of matrix will slow down this process, because this process, yeah, it will cut your molecule into smaller molecule and into ions. Yeah. If you don't mix with matrix, this process will destroy your molecule, and it's very difficult for you to analyze your molecule. So we mix with matrix so we can soften this process a little bit. Yeah, we don't break the molecule too much, because in mass spec, yeah, still remember in 3402, basically you break your molecule into smaller fragments in mass spec. Yeah, so you get fragments, right? So MALDI, there are two types of MALDI. Yeah, linear and reflector. Yeah, this is a linear MALDI. This is your sample, and this is the detector, and this is reflector. Yeah, reflector MALDI-TOF. Yeah, reflector MALDI-TOF, right? So the difference is resolution. Yeah, reflector mode has better resolution than linear. Yeah, for example, if you have 10 fragments with different sizes, yeah, there are small fragments, there are bigger fragments, there are middle-sized fragments, right? And these fragments, they have to run from here to detector. Which one that can reach the detector faster? Of course, the small fragment, right? Small fragment can run faster. They reach the detector faster. And bigger fragment, they will reach the fragment later, yeah, because they are big, yeah, slow sedikit lah. Masa lari tu kan dia slow, right? And from there we can know their size, yeah. But then if you have reflector mode, the separation is better, yeah. The separation is better because at this point, yeah, at this point it really separates the molecule from small molecule to big fragments, yeah. Because it reflects, yeah, the separation is better. Okay, so that's the difference between linear and reflector mode of MALDI-TOF MS. Okay, this is what you will see. Yeah, this is what you will see. You have peaks from the fragment. Yeah, this is the protein from cancer cell. You cut from the gel and then you digest into smaller fragments. Yeah, this is the sequence of the protein. And after cutting, it becomes this fragment. Yeah, it becomes fragments. 1, 2, 3, 4, 5. Yeah, 5 fragments. Yeah. And then you run to mass spec and you see their mass, yeah, their molecular mass, and you compare with theoretical mass spectrum, and from there you know the sequence. Yeah, for example, the size is 275. Yeah, based on mass spec, gram per mole. For example, yeah, just example, yeah. And then you compare with theoretical mass spectrum. 275 means peptide with this sequence, blah, 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 blah. It means this peak belongs to this sequence. So you must have a database, yeah. You must have a complete database with the mass of each peptide. It's a huge database, yeah, with the molecular mass of each peptide sequence. Yeah, so this is how we do the experiment, yeah. There are certain sequence that we can identify using mass spec, yeah, and from here we know what protein that we have in cancer cells. Yeah. Yeah, so you compare with the database, yeah. So this is the database. This is the sample from the spectrum. You process the data and then detect the peaks. You create mass list of spectrum, yeah. This is the list. And you compare with the database. Yeah, you compare with the database, and from here you get the result. What kind of protein you have in your sample. Yeah. Right. So yeah, this is the same. Okay, let's see the techniques. Okay, this is other techniques, yeah, other than MALDI, yeah. Other than MALDI-TOF, we can use ESI, yeah, electrospray ionization, yeah. When the protein is small, you can use ESI, yeah, smaller protein, yeah. Smaller protein. You can use ESI. Okay, smaller protein, you can use ESI because it creates many fragments. Yeah, it creates many fragments. When your protein is big, the fragment will be too many. It will confuse you. So that's why ESI is suitable when the protein is small. Yeah. It doesn't have matrix. It doesn't use matrix. So this is example of a protein, yeah, trypsinogen, very small protein with molecular weight around 24,000. So you can see a lot of peaks that corresponds to different peptides, yeah, different fragments, fragment 1, 2, 3, and etc. Yeah. So this is what you will see in a mass spec spectrum. All right. So this is another technique. We call it as MS-MS. Yeah. So you have two MS combined into one. We call it as tandem mass spec, right? So in previous mass spec, yeah, in previous MS, you have only one MS, one mass spec, and you get this. You get the size of each peptide fragments, yeah, and then you compare it to the database, yeah. But in MS-MS, what you will get is your peptide will be chopped off into amino acid, yeah. So the first mass spec will chop your protein into peptides, chop, 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 chop. And then the second mass spec will chop your peptide into amino acid, chop, 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 chop into amino acid. Yeah. And the result is you will get the sequence of amino acid of your peptide. Yeah. We don't have many in Malaysia because it's very sophisticated machine. Not many people in Malaysia can interpret MS-MS result. Yeah. I did once, not in Malaysia, in the US. I was lucky that I used MS-MS in my research. Yeah. So this is what happened in MS-MS. Yeah. So this is the peptide. And by using the second MS, yeah, in MS-MS, they will chop the peptide into amino acid. Chop, 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 chop. And then you get the amino acid. Yeah. You get all this amino acid. Chop. That's it. Potong, cut, cut. Right? So, all right. Okay, so yeah, all these are the process. Yeah, what happened? Yeah, when you cut the peptide into amino acid. Yeah? So you get the sequence of the amino acid. Yeah? Of course, there are some noises, missing peaks. You can ignore that. And yeah, this is how you identify protein with MS-MS. Yeah, instead of using the database, you can really cut the peptide into amino acid, and you know what protein you have. And this method is useful, especially when you are working with new protein that don't exist in the database. Yeah. So because maybe your database is not updated, you're working with a totally new protein, yeah, not in the database. So you have to use MS-MS, yeah, to see the sequence of your peptide, to see the sequence of your protein. Yeah, the spectrum is more complicated, see, compared to the previous spectrum. This is more complicated because you see the amino acids, yeah, all the amino acids, right? And you can identify the peptide. We call this technique as de novo peptide sequencing. Yeah, de novo means from scratch. Yeah, from scratch. So instead of identifying the peptide, you identify the amino acid. Yeah, and then you can see the sequence of the amino acid. Yeah. All right. Which one is more accurate? Yeah. You search from scratch, or you search from database. Again, it's different case by case. When your protein is not new, it's good to have to use database. It's faster. Yeah. But if your protein is new, it's not in database, so you have to do MS-MS. You have to do de novo analysis. Yeah, you have to analyze from scratch. Yeah, you chop your peptide into amino acids. Yeah. So this is de novo. Yeah, so you get the peptide. You use a database. You get the peptide as well, but the process is different. Again, depends on how new the protein is. New protein, you use de novo. The protein is in database, then your life is easier. You can use the database search. Yeah, this is which one is better? Again, depends on your case. Yeah, so yeah, that's all for the second part. Any question? Any question?
Yes. For
What
the
question?
first part,
Yeah.
NMR. Proline cannot be seen in NMR.
Yes.
Proline.
Yes. Cannot.
So how can we identify the proline?
Mass spec.
The method.
Mass spectrometry.
Oh, okay. Thank you.
Yeah. So to identify the protein, we rely on different tools. Yeah. Just like what you learn in CHM 342, right? To identify the structure of molecule, you need IR, you need UV vis, you need mass spec, and you need NMR. Yeah. Because one method is not sufficient. Yeah, one method is not sufficient. Okay. For example, in NMR, yeah, if the molecule is symmetrical, you cannot see you cannot get all the information, right? Because you cannot get all the peaks when the molecule is symmetrical. Yeah. So that's why you need mass spec. So that's why you need IR or UV vis. Yeah. The same thing. Yeah. Proline cannot be seen in NMR. So that's why you need a mass spec, yeah, mass spectrometry. So they are complementary. Yeah. So you need more than one tool to see the structure of the protein. Yeah. Good question. It means you pay attention to what I said. Okay. Any other question? Don't forget to sign your attendance. Eh? Any other question?
No.
All right. Okay. So I take no as no, no question. Yeah. So if no question, then that's all for today. Yeah.